So it is, we have seen that there the sun rays, uh, you know, when it reaches the Earth's surface, depends on the nature of the surface that we have seen, right? In the same manner, there is, look at here, this table shows if the insolation received at equator is 100 units. For example, it is given that if insolation received at 0 degree latitude, that is equator, if it is 100 units, then there would be 75 units at 45 degrees north latitude. Okay, and 50 units of insolation is received at a polar circle, that is 66 and half, either Antarctic or Arctic circle, and at 90 degrees pole the insolation received is 40 units. Okay, so moving from equator to the north pole and south pole, gradually insolation received on earth's surface decreasing, right? This is because they fall slantly. I'm picking out that, I'm selecting the text, my dear students. Look at that. This is the one, slanting towards the poles. That means sun rays does not fall vertically on all the places of the earth, right? One thing, it is spherical in shape, earth is in spherical shape, and it is rotating and revolving. So in its rotation, it bends 23 and of a angle, so that certain part of the earth surface there is a sun rays falling diagonally, that means slantly, not vertically. That what we call, in other words, angle of incidence. Angle of incidence instant. When the sun rays fall slantly at poles, this is called angle of incidence. The angle at which the rays fall on Earth's surface is called angle of incidence instant. So to understand the angle of incidence, there this table is given, right? So why does the sun rays, by the table, from the table, the insolation, why does the insolation is 100 units at equator and 40 units at north and south pole? It is because of angle of incidence instant. So the amount of energy received on the earth surface is what to call different from different places instant. So here, what to call it, changes instant. The amount of energy received on the earth's surface is called angle of incidence instant. So even though more intense sun rays fall on equatorial region, it is usually cloudy after midday, right? And equatorial regions are not as warm as the regions immediately north or south of them. There at equatorial region, we see temperature is high and rainfall also high instant, so that it turns to low pressure belt. So here, this is not, as the earth goes around the sun, we see that the angles of incidence constantly change. That means the sun rays falling on earth's surface will change, moving from equator to north or south pole as earth rotates. Instead, when earth goes around the sun, then in the course of time, sun rays falling on the earth's surface will change. Thus the angle of incidence increases in the north during the months of November. Angle of incidence at northern hemisphere increasing in the November. In November, sun rays fall vertically on Tropic of Capricorn. I'll take you there. Wait a minute, my dear student. This is a diagram. It will help you to understand clearly where it is. I think this one. No, one more is there. Hmm, just a minute. I think it is in the first chapter. No, there, no, there. Let me take this only. Okay, this is what you call our Earth. Understand? This is equator, and here it is there below here, Tropic of Capricorn is there, and at north Tropic of Cancer is there, right? So November is the month we see the sunrise fall vertically in southern hemisphere. Vertically sunrise falls in southern hemisphere, right? Vertically falling here. Then what you call Earth, they are equator is a slant here because equator is it is Earth is rotating, so it bent, it tilted 23 and a half degrees angle so that the sun rays does not fall vertically on northern hemisphere, right? So that the angle of incidence increases moving from equator to north and also to the south, understand? So here in the month of November we see the angle of incidence increases in the north, and December, November and December, and it decreases in the month of May and June, right? Because in the month of May and June, the sun rays fall vertically on Tropic of Cancer, right? That is 23 and a half degrees north latitude, right? There vertically to falls. Then where does the angle of incidence increases? Angle of incidence increases moving from equator to south pole in the month of April, May, and June. Understand? So here the insolation received on Earth's surface depends on angle of incidence also. This is another point you need to keep in mind and understand it, that there is a change in temperature from one place to another place depending on the angle of incidence, understand, right? Another factor also there which influences the what you call the temperature of a place, that is land water relationship. What is that? Land water relationship. This will study in 10th class as a land water relationship, and here in 8th class you are studying it land and water contrasts. Contrast in the sense difference. Temperature distribution over land and ocean are completely different and varies, and this will be clear if we measure the temperature of different places over different continents and oceans. Okay, if you open the atlas and find out the map showing the temperature, you will understand that temperature is different at different continents. Understand? In the Europe, the temperature is moderate. When it comes to Africa, temperature is high, right? So at different continents, the temperature is different. Understand? So why it is different? Because there is land and water difference is there in absorption of heat, understand? My dear students, land is to be considered as a good conductor of heat, whereas water bodies are different, understand? When land gets heated and also cools quickly, whereas oceans take much time to become heat and cool. That means there is a difference in the absorption of heat by land and water body. Okay, land absorbs the heat very fast than the water bodies. So the land becomes heat very soon, whereas water bodies becomes heat very late when compared to the land. Understand? So that is the difference in the absorption of heat by land and water bodies. Understand? So why does it is like that? Why does not land and water bodies become heat at the same rate of speed? Because this is a point you know well that water body constitutes 71 percentage on the Earth's surface, right? And remaining 29 percentage of the Earth's surface is covered with the land. The land part on the Earth is very little when compared to the water body is very large, so it takes very long time, so that we says it heats, it becomes heat slowly and releases heat very slowly, right? Land absorbs very fast and releases heat very fast. So due to this what do we see? So when land becomes heat very fast, then the temperature on the land is high than the temperature recorded on water bodies. That means the temperature is different on the land part and water water part, right? That is water bodies. Instead, if you look at page number 22, you will understand that different colors are given for different places on the continents to understand how much temperature is there and why do we have temperature differences at each places. Look at this, my dear students. um this I'm rotating. Yes, it's not rotating, I think so. Just a minute. Okay, I will make it like this. So, mm, 1 minute. It has to look at this. I'll just show you. Map this one. Right, my dear students. Yeah, okay, right. This that's this time. This is the map you will see here, right? World map. Okay. What do you see here, my dear students? Temperature given in the index. See, Celsius per minutes per square meter. Wherever the blue is there, there it is 2.5 Celsius per square meter. And when it comes to the last 8.8 per meter per square meter, so different colors are given here. See that. In Africa, especially in the north part of Africa, where the red is there, that is a high temperature, right? And very low temperature is blue color. So different colors are given to understand that temperature is different at different places over different continents and oceans. Instead, on the continents, it is given. On the oceans, it is given only the blue, right? See, here it is what to call in a western part of India, where Thar Desert is there, and Arabian Peninsula, then Sahara Desert in the north part of Africa, then what to call Kalahari Desert in the South Africa, right? And Sonoran Desert in North American continent. Then what to call here also in South America it is there, the desert part. So temperature is different at different places. Understand? So what I want to say that the angle of incidence is a reason one, and another reason is that there is difference in the absorption of heat by land and water bodies. Understand? So can you tell why there is difference in the in heating of land and water? This question is related to the our explanation. What the, what is the reason for differences in the heating of land and water? Because land part is very little compared to the water bodies, and the land part absorbs very fast than the water bodies. Understand? This is the reason. Understand? The next, we see that the heating of the atmosphere. Okay, how does atmosphere becomes heated? Dear students, in the last class I have given to you showing this picture that figure 2.2, this one I'm taking, yes. Here figure 2.2 is below this figure 2.2. What is there, my dear students? Insolation and terrestrial radiation, right? Terrestrial radiation, in the sense already we discussed, it is a radiation of heat by the earth, right? So when earth becomes heat, then excessive heat, extra heat received by earth is reflected into atmosphere, that is called terrestrial radiation, right? You may get surprised that atmosphere, that is air around us, air which is surrounding the earth, is not heated directly by the sun rays. It is not by sun rays, in the sense it's not by solar radiation. It is heated actually by the Earth's radiation, that what we call terrestrial radiation, right? So in fact, actually the sun rays uh, allows to the sun rays to fall on earth surface, then earth becomes heat. After becoming heat, earth reflects such a heat into the atmosphere. In that way, atmosphere becomes heat. Understand? So heating of atmosphere, in the sense you need to understand that atmosphere becomes heat by the terrestrial radiation, that is earth's radiation, right? It is not by the solar radiation, right? This what you call, you need to keep in mind. This in turn being begins to radiate heat, which heats up the air around us, and that is why we see that at lower layers of the atmosphere are warmer. Okay, lower layers of the atmosphere, this is the I was writing the text. So lower layers of the earth is warmer than the higher layers of the atmosphere. You know, atmosphere consists of different layers, right? Troposphere, stratosphere, hmm? Then ionosphere, what you call thermosphere, ionosphere. So what is the lower layer? Troposphere. In a troposphere, the temperature is high than the what you call stratosphere, right? This in ninth class you will study again in detail. Okay, so just to keep in mind that moving from earth surface, okay, from earth surface to higher places, higher altitudes in the sense height, going from surface of the earth to higher altitude in atmosphere. Keep in mind, in atmosphere, it's not beyond the atmosphere. Within the atmosphere, temperature declines. Is it clear, my dear students? So that, have you identified that standing on the ground floor, you feel it is somewhat warm. When you goes to stand on fourth or fifth floor of the building, There you will see it is a pleasant atmosphere. The cool air is blowing and surrounding you, right? Have you identified when you stand on fourth floor or second floor? This is because that there is a temperature decline moving from Earth's surface to higher altitude, right? It means that we need to think that atmosphere is heated by the Earth's radiation. That what we call terrestrial radiation. So up to now, what we have seen, my dear students, we have seen that energy. Sun is the powerhouse of energy. First point in this lesson. Second point, we see that energy is received in different forms. That is light and heat. Energy comes in the form of light and heat. Uh, one of the student have written the assignment showing that thermal energy, solar energy, that is different. Here the concept we have to understand. Okay, so in how many ways energy is received, light and heat. That is second point we have seen, right? And this energy received by Earth is different at different places that we have seen, right? Energy received by Earth is different from different at different places, right? The energy radiated by the solar sun is called solar radiation that we have seen. Next point. Then another point we have seen that energy, what to call the sun rays, solar radiation coming to the earth or earth absorbing it. Okay, incoming solar radiation is called insolation, right? That is the insolation. Insolation is different at different places, whereas solar radiation is constant. That we have seen, right? And another point we have seen that there the angle of incidence is different from one place to another place, moving from equator to the poles, so that the temperature is different from one place to another place. That is the point we have seen. The next point what we have seen that land water concentration, right? Land absorbs very fast and becomes cool very fast when compared to the water body. That is also we have seen. Then another point what we have seen, heating of the atmosphere, right? Atmosphere becomes heat by the terrestrial radiation, not by the solar radiation, right? That is the reason we find that temperature decreases, what to call moving from lower layers of the atmosphere to upper layers of the atmosphere. So we find it is warmer near to Earth's surface, and moving to higher altitude, there will be gradually decrease in the temperature recorded, right? The next, heat balance. What is a heat balance? We will see, right? The heat the Earth receives from the sun is radiated back by the Earth in different ways. Okay, how it is we see that one third of it is immediately reflected back into the space when solar radiation reaches the Earth's surface. If the 100 percentage of solar radiation is trying to reach the Earth's surface, in that one third is reflected back into the space. One third is reflected. Instead, three parts. Then what is left? One part. Instead, so the rest, remaining part, heats of the Earth surface of the Earth, and that also in turn heats the water atmosphere and also radiated into the space. My dear students, maximum solar radiation is reflected into the space. A little solar radiation is reaching to the earth surface. In that also a little solar radiation which reached the earth surface is enough here to make earth surface warm and also enough to make the atmosphere heat. Understand? So what I want to say here that a little solar radiation received by earth is enough for making earth warm and atmosphere also. This complete radiation of heat received from the sun is important here. So if the entire heat is not radiated back, that means suppose 100 percentage of the solar radiation, if it is observed by Earth, what would happen? It would make Earth very hot, hotter, and very hotter, so that Earth may turn to fireball again, right? But it is not happening, right? Continuously, solar radiation is reaching to the Earth's surface. Then our Earth should become fire, another fireball. Is it happening? No, right? If it becomes a fireball, there won't be existence of a life on the Earth's surface. But we are living along with us many animals, plants also surviving on the earth. It means that much of the heat observed by the earth is not stored with the heat, not stored by the earth. It releases into the air and also releases into the space. Instead, how much it releases? It releases excessive heat. What is by excessive heat here? The amount of energy received by Earth is also radiated into the space and air. So here the point is that how much it is radiated, right? So it observes to make Earth warm. After Earth becoming warm, then the excessive heat is reflected into the air and space. In that way, Earth maintains a balance in the heat. Understand? So, one example I want to give that when our body becomes heat, then what do we do? We'll go on taking some sip of water, right? Or we'll go on sitting under a fan, right, to balance the heat of our body. Similarly, every object in the nature will try to make it balance. Understand? So Earth also maintains balance in the heat observed by it. Understand? So it radiates the excessive heat into the air. Understand? So that see, don't think that it will radiate total heat observed. What happens if it radiates total? Then it becomes cooler and cooler, so that Earth becomes a very cold planet, so that there won't be existence of life. Two things are danger. Instead, if total heat of the Earth is radiated into the space, Earth may become cool, right? It may turn to cold planet. If total heat is observed by Earth, then it may turn to fireball, right? So Earth may turn to hotter if it observes total heat, or if it releases the total heat into the space, it may turn to cold planet. So these two things are not happening here, right? Always we see that Earth is somewhat warm, right? It means that when it becomes excessive heat, the excessive heat is released into the space. When it's going to become cooler, then it absorbs what you call the solar radiation. In that way, it maintains balance in the heat. That what we call heat balance. What we call heat balance instead. So, have you observed absolutely flat land over a long stretch? Everywhere the land seems to be slightly undulating and sloping, right? In the office of our school, we see the table is flat, right? But Earth's surface is not flat, right? We see that all the places on Earth's surface is undulating. Somewhere it is what you call high, somewhere it is low. There is sloping, right? So these all are the what things variations we find on Earth's surface. Understand? the undulating nature. Only 6 minutes is left, my dear students. I'll stop here completing this. The undulating nature and sloping results in the heat observed by the land is different, right? So there is a variation in the amount of insolation received by the land due to the unevenness of the land, right? Or what you call not uniforming of the land surface. The land surface is not uniform, right? We have mountains, we have plateaus, we have plains, and their heights are different. Somewhere we find valleys, right? Somewhere the land is sloped, somewhere we see that a gentle slope. So lot of variations are there on earth's surface. So all these variations are the reasons for receiving insolation in different amounts. Understand? So will this happen more on flat land or sloping land? Where do we see that this one? Well, two sides of a mountain front receive the same amount of sun rays. No, right? What could be the reasons for this? So one question is asked to you that why does this what you call two sides of the mountain does not receive the same amount of sun rays, right? And where do we see that the insolation is high, whether it is on flat land or sloping land, right? So this you have to go through with the angle of incidence. Where is angle of incidence? Sloping land. So there will be less insolation than the flat land, right? Similarly, it is also what the both sides of the mountains does not receive the same amount of sun rays. Instead, so some gases here, some gases like carbon dioxide prevent radiation of heat from the earth. This is the point which is connected with global warming, my dear students. Instead, there is carbon dioxide in atmosphere along with several gases, right? In that oxygen is very important for us. Along with oxygen, nitrogen, uh, then argon, neon, uh, what you call water vapor. We find a carbon dioxide also, and this carbon dioxide does not allow the heat of the earth into the what you call space. Instead, carbon dioxide in the atmosphere increases by burning the diesel, using the vehicles, and petrol also by burning the petrol which we are using the automobiles. uh, when we cut down the forest, then the carbon dioxide increases. So when carbon dioxide proportion in the atmosphere increases, then there will be less heat radiated into the space. That means the heat reflected by earth. Okay, when earth reflects the heat, excessive heat, it has to move into the space, but there is a carbon dioxide forms a layer, and such a carbon dioxide stops the excessive heat. In that way we see that temperature across the globe increasing due to the carbon dioxide much amount, and that increasing temperature across the globe is called global warming. Global warming in the sense temperature increasing throughout the earth, throughout the planet earth, is called global warming, right? So what is the reason for one what is the reason for global warming? It is increasing in carbon dioxide, right? What happens if the carbon dioxide increases? Then the heat released by earth is not radiated into the space, right? Much of the heat released by earth is prevented and stopped in atmosphere only. So it leads to global warming, right? Last 2 minutes, my dear student. We will conclude here, okay, about these factors. Okay, we have seen that. Are you clear? We have seen land water concentration, then heat balance, we have seen how the earth maintains heat balance. Angle of incidence, we have seen where it is. Just a minute. Here it is. Angle of incidence, we have seen, right? So this is about today's class, my dear students. One day I'll keep a class for doubt sessions. Please, all of you go through the first and second lesson. After completing this first and second, after completing the second lesson, we'll go for a doubt class. Okay, right? So what is meant by heat balance? Your right answer. What is heat balance? Okay. Then what is the relationship between water and land part? Okay. Thank you very much, my dear students. I'm going to conclude the class. I'm going to start now. Okay.